you're talking hundreds of documentations that's coming into companies. They're trying to have their staff analyze so much documentation that's coming in. It just becomes very daunting, or you have to hire so many people to do that, but AI should help streamline that process.
That's what AI is great at. It can sort of take any problem that you give it and sort of reason itself around any issues like that. So you don't have to keep tweaking it every day to get it to work, or sort of, have your staff work on really boring sort of data sort of analysis that is just no one really wants to work on anyway.
Are ML and GPT, are they one and the same? And I guess the short answer is yes and no.
Hello, everybody. Welcome back to another episode of Make an Impact podcast. I'm your host, Makoto Kern. I have here, as usual, suspects, my integration team, Brynley and Joe.
Hello.
Hey.
You guys.
Good to be back.
Yeah.
All right. So today, on today's episode, we will be discussing if ML, machine learning, and GP models are one and the same.
Yeah, so
pretty technical topic.
Yeah, but one that I'd be keen to kind of hear the sort of, not assumptions, but the experience that we've had with it, because my experience with machine learning is, it has kind of built one sort of construct, and then dealing more and more with AI and especially GPT models, you do kind of go, well, are ML and GPT, are they one and the same? And I guess the short answer is yes and no. So we'll kind of dive into that and unpack some of the different areas of machine learning and GPT. So really, I found kind of those terms are used interchangeably by a lot of people. They'll be like, okay, well, we've got to do machine learning. And you're like, okay, are you talking about GPT, or, what are you talking about? So that kind of causes a bit of confusion about their differences. And really, in summary, I guess both fall under the broader umbrella of artificial intelligence. However, they really serve distinct roles. So if we look at GPT models and you think of OpenAI's GPT-4, all the releases, Anthropic's Claude, Google's Gemini, they kind of represent a specific subset of machine learning designed to process and generate human-like language. Whereas if you look at something like traditional machine learning, it really encompasses a wide range of techniques, which are mainly kind of focused on pattern recognition and prediction across various data types. So you're going to see that there's overlap, and again, we'll kind of explore that. So the misconception arises really when these GPT models are viewed as the entirety of machine learning, rather than really one powerful example of its application in natural language processing. I think just by understanding this distinction, it's crucial for kind of accurately grasping how AI innovations like things like Gemini, Claude, they fit into the broader world of machine learning. So I think to best articulate the differences, we can look at a few areas, things like, the general definition, the type of learning, the purpose and output, data and training, usage and applications, and lastly, flexibility. Because I think just doing this exercise, we haven't dealt with all types of machine learning. It's interesting to see the overlap and the differences just by looking at these kind of various areas.
So out of interest, this is my assumption, and then tell me if I'm correct or not based on what you're reading through there. So machine learning is the practice of creating models using data, transformers, whatever you need, algorithms, which actually creates a model at the end of it. That's the application of machine learning. That's what machine learning is. Your output is always generally a model that you have at the end. And ChatGPT, that model is really just a subset of machine learning, right? It's gone through the same process. ChatGPT is really a model, but it was also built by machine learning. Is that correct? Is that the right way of saying it too?
Well, I think so from my understanding. And again, there's so many different applications, but it's also, I think what we'll touch on is also the pre-training that's different. So, usually you have your training data set, whereas GPT, you really are looking at, well, this is pre-trained on a certain data set. So let's look at the kind of definitions. I think that touches on those.
Yeah. So it's kind of more the way of traditional usage of machine learning. You do get a model at the end of it, but how that's built compared to how GPT is built, or a model like GPT is built, are very different. Is that kind of where we're going with this? Just
exactly. Yeah. And I think, again, those differ in the various sections that we'll look at, because there is the sort of broad definition.
I'm assuming to get even more kind of nerdier and technical. When you get into machine learning, like, are they using specific like neural network patterns and how they're creating it, or even fuzzy logic can be considered machine learning because you've got a certain model that you're training for. And like you said, it's a very specific thing that you are training, like fuzzy logic. If you're automatically adjusting like a temperature gauge or whatever, it's not necessarily neural networks, but it's fuzzy logic where it's like you're just trying to get a close enough temperature setting and have it automatically detect and adjust itself.
Yeah, it is. And that's probably worth saying. So if we look at machine learning and its definition, so it's saying a broad
Mm.
field. And I think that's what's important is it is very broad and it all depending on the application. So a broad field within artificial intelligence that focuses on creating systems that can learn from data. So that's sort of things like developing algorithms that analyze input data, learn from it, and make decisions or predictions based on that new data. So you can think of things like image classification, to train to identify within images containing a cat or a dog, or fraud detection, like looking through bank transactions and kind of going, okay, these look like fraudulent transactions. So varied, but obviously creating the system that learn from the data. Whereas you've got GPT models or generative pre-trained transformers. So that's a specific subset of machine learning. And that's obviously what we've talked about before, the large language models. And that's using neural network architecture. And that's where obviously the transformer comes in. And they're trained on vast amounts of text data to understand and generate that human-like language. So
And
there's that sort of
you're probably
generating aspect as well.
yeah, and you're probably, I wonder if with, and to get into like maybe Teslas and how they have self-driving cars where it's a different model because they've got tons of data from a video standpoint,
Mm,
but then you can throw that car into any kind of situation and it learns on the fly, kind of, instead of having pre-programmed set of data. So it's,
mm,
like you said, it's more, I guess, generative versus just
mm.
straight kind of feedback and trying to learn by teaching it millions of different models or billions.
Yeah, it's a good point. I mean, I think there's so many probably different sets within that as well. I mean, you're looking at that where it would be machine learning because it's got to take all those, the pattern recognition and things like that and apply it to, the video feed that's coming in. But it has to have gone through that machine learning process of a car, a truck, a bicycle, and scenarios, beforehand. So it's maybe not, in my understanding at least, not generating the same as the transformer kind of models that are actually creating new. It's more analyzing again because it's still data
Yeah.
that's feeding into something like a self-driving car and going, okay, identified that, do that. So those are the basic definitions. But then we also look at the next area, which is the type of learning. So, looking at machine learning, you've got models that are typically trained for specific tasks. So that's things like classification of data or regression or clustering. Some examples of like house price production or supervised learning, where a machine learning model can be sort of trained to predict the price of houses based on features. So it looks at like, okay, what's the location? What's the size? What's the number of bedrooms? Or something like customer segmentation, where it's unsupervised learning, where retailers can use unsupervised learning to cluster customers based on their purchasing habits or kind of enabling things like personalized marketing. So, very much, I guess, looking at those specific tasks. And again,
Yeah,
coming
it's a
back to
very
GPT.
narrow objective
Yes,
what
that's it.
that does, yeah, for a very specific task. Yeah.
And then while that can be supervised and unsupervised, you look at the very much unsupervised nature of GPT models, where it's that unsupervised learning during, again, the pre training phase. So, and that with the goal of really learning to predict the next word in large amounts of text. And that's where, again, I think, if you check out our podcast on emergent behavior, that is, that's something that's come from this as well, come from this unsupervised learning where it's been given one task and it does something, it does a whole lot of other things that were unexpected. So again, looking at
Also,
use cases.
yeah, sorry, I was just going to say too, the great thing about the GPT model is that it's almost, because it's so general, it can be used for a wide application of things. It's not just that narrow, specific pinpoint task
Correct.
that, standard machine learning models have been made for. But what's also great about fine tuning is obviously the process of taking an existing model and then adding more specific data and working with it in a different way, or sort of fine tuning it to a more specific task. You can take like something like a GPT model, and you can obviously just prompt it in certain ways to get to what you want to do. But if you really want to go to the next level, you can fine tune it and provide it even more specific and public information that doesn't really know like your own company information or your own personal information. So fine tune it that way to get it to specialize maybe in your company's knowledge or your company's domain knowledge as an option. There's loads of different options around that. But yeah, that's what's great about them too.
Well,
I assume there's
that's
a
exactly
difference. Oh, sorry. I assume there's a difference too between video or image processing versus video generation, like Midjourney and all that. That's more GPT versus the image
That's more machine
processing.
learning, I would almost imagine, right, Bryn? If you think about it,
Well,
like that,
I,
something
I would say
like
it's a
that's
mix.
creating video. Sorry, that's you think it's a mix.
Well,
Okay.
not a mix ball. It's imagine that it has to. So you look at some of the transformer, the video kind of transforming technology that doesn't have enough training data on things like hands or walking cycles. So it's very much about the pre-training data that makes it. So it's doing a transformer, and I suppose it's more GPT in terms of it needs that pre-training and then it generates. So it is flexible and kind of what you were talking about, Joe, you kind of read almost into the next section, I think, which is great, about purpose and output. Where you can say, well, machine learning models are, task specific, meaning that their architecture and training are designed to solve a particular problem. That output depends on the specific application. So whether it's like spam email detection or disease diagnosis. And again, getting back to GPT, as you were saying, Joe, completely versatile in terms of their output. And I think that's where we can see things like the video generators to be similarly versatile in that they can generate a lot of different outputs based on all that pre-training data.
Yes,
so
generating more like a new thing, a new output versus just analyzing what's there.
Yeah, exactly. So
yeah, just have interest looking at Sora, just because I was curious myself, looking at Sora. That does seem to be based on a machine learning based system. It's not really built off an existing GPT model. It's not fine tuned.
Oh, interesting.
It specifically uses a diffusion model combined with transform architectures. So it's very much, obviously, again,
well, the transformer architecture would be very much GPT.
Yeah, GPT models are made very similar. Yeah, but it's not like it's taken from a GPT-4 model and fine tuned, or it doesn't rely on a GPT model to operate. It's definitely its own thing, using very similar methods of creating it. But yeah.
Oh, that's interesting. So the next section we can look at is also the data and training. So machine learning really requiring structured data sets, whether they're labeled or unlabeled. So you can think of things like tabular data, images, time series. They're trained on specific task relevant data sets. And again, like all the other things like stock price prediction, image recognition, you've got that structured database. Whereas when you're looking at GPT, it's trained on a huge data set of unstructured text. So whether it's books, websites, articles, it's got to find and learn those patterns in that language and the grammar, even the facts, to really output what it does and do a lot of the things like being able to answer the questions and that we ask it, and filling in blanks of even incomplete sentences or paragraphs. It is quite different there just on that sort of data and the way it's trained. Then looking at the second last section, which was usage and application. So machine learning is used in obviously a wide array of industries and fields. And we can think of that, exactly what you're saying, Makoto, things like self-driving cars, that machine learning models that process that camera and sensor data to detect objects and make real-time decisions for safe driving. Whereas GPT, it's specifically used for natural language processing tasks. So again, typical use cases, the chatbots or the content creation, that sort of thing. And then last of all, we have flexibility. So this is sort of looking at machine learning models that are coming back to what we've covered already, highly specialized and tailored for those narrow tasks. Whereas the GPT are just much more flexible, adaptable, and they're multiple text-based and even image-based tasks now. So I think that's where it's interesting there there's certain similarities, but it does seem that the common thread is that machine learning is a lot more specific and scoped,
Yeah.
and using structured data, and the GPT is a lot more taking that unstructured data and being able to actually create from it, not just analyze.
Mm.
So
Yeah, very different
yeah,
use cases. Yeah.
mm, so I thought it was pretty fascinating, and kind of summarizing that machine learning is really this sort of broad category that includes the various techniques for training models to perform these specific tasks. While the GPT models are really this subset of machine learning models specifically designed for, I guess, understanding and generating natural language, with the sort of focus on outputting things that are more versatile.
The great thing is, as we see how models are being used in multi-agents, you don't have to choose one or the other. You can choose the GPT model as your interaction with the more fine-tuned models behind it, and the agents can talk to each other, and one can be specialized at finding you that exact image that you wanted and respond it back to GPT model that gives it back to you, and you can say, oh no, that's not what I wanted. I wanted a red hat on the reindeer, and then
Mm,
it'll send it back to the model, configure it, like prompt it in a certain way, and actually be able to work with that agent a lot more intelligently than you could even. So with that
mm,
sort of more fine tuned machine learning model. And yeah, it's just really interesting to see where it's going to go with that. It's all the models talking to each other, and there's going to be more popular models coming out,
mm,
very much specific to these tasks. Like Sora would become the video model, and that's what everyone uses, and almost
mm.
becomes like a foundational model for video sort of generation
Yeah.
going forward. And all the other services out there are just using it as a service in a multi-agent approach to generate that bit of video that you wanted and give
Mm,
that back to you. Another one generates the images for your presentation. The other one generates the text,
mm.
and all working together at their own little
We look
tasks
at,
is, yeah,
like
pretty
1.0
cool
with
to
with
imagine.
reasoning as well, and go off and go, okay, this
Yeah.
is your this
Mm.
is your scientist, and this is your
Mm.
um, biologist, or whatever. I don't know, whatever kind
Yeah.
of function you want.
Mm.
It's yeah, it's going
Yeah.
to be pretty exciting.
Yeah, I
Mm.
think this is probably an important point too, just within what we do here at Impact is trying to identify that within the organizations. Where can processes be automated and made more efficient, and what tools to integrate? Whether that is a machine learning tool, is it more of a specific AI tool that's been created out there, or is it something that we help customize and build specific AI agents to help companies make that more
Mm,
efficient and then not cost so much either to build it and see ROI pretty quickly.
mm. Yeah, agreed. I
Yeah, the
think that's
model
the.
as a service approach is just becoming so amazing with that. And our
Hmm.
speciality and understanding which are the good models to use, not just in terms of accuracy, but in terms of cost effectiveness. Yeah, I think it's a huge help to anyone who needs that. Because when you try and look, okay, I need something to do document classification for me, where do you start? There's just a million options out there. But knowing what our experience has been in leveraging certain models and what we see in the results are from those and the services around that, it's not like you go and have to build your own models and your own systems to actually do this. There are great services out there, but there are loads, and it's great to talk to people
Hmm.
like us because we've just gone through all of this already. We've had some really great results using some of these, and just really great results integrating them into existing systems that you're using. It doesn't have to be something standalone that's outside of your existing software stacks. Really easy to integrate these services in, which we've been doing a lot of recently too. So it's just become
Agreed.
great. It's just I can't
Yeah.
I'm always, it's just every single problem, there's always a solution for it with AI at the moment. And it's just, really fun to, and just
It's
exciting to
exciting
start
space.
implementing those.
Yeah.
Mm,
And I mean, we're seeing
yeah.
this across almost every industry where it's being disruptive, or it's very helpful in a positive way, being disruptive, where, we've had clients where they're in the kind of the legal space where they're trying to optimize documentation, hundreds of pages within documentation to analyze. Maybe it has to do with mortgages or banks, and there's
Mm,
legalese that they have to identify and make sure that all the things are correct within the paperwork that has to be signed. And you're talking
mm,
hundreds of documentations that's coming into companies that we did for this one where they're trying to have their staff analyze so much documentation that's coming in. It just becomes very daunting, or you have to hire so many people to do that, but AI should help
mm.
streamline that process. But then
Yeah.
we've got energy companies that we're helping, to cybersecurity companies as well. integrate that AI and make it more user friendly.
And
Absolutely.
it's all often really mundane tasks too that AI is just great at doing. I mean, even sort of humans doing that, looking through 10,000 documents a day, trying to like pinpoint errors within them, it's just not feasible. And even some of the software that's traditionally been out there to do that has been tuned to do that, can only work within a very narrow scope. That's what AI is great at. It can sort of take any problem that you give it and sort of reason itself around any issues like that. So you don't have to keep tweaking it every day to get it to work, or sort of have your staff work on really boring sort of data sort of analysis that is just no one really wants to work on anyway. Get them to work on more exciting things that can actually provide much more benefit to your company rather than just slogging through data. So it's great.
That is the interesting thing. I mean, you don't often think of employee satisfaction as being part of the value adds when you actually integrate AI, but it's definitely one of them. Making employees much more efficient, and all the, as you said, mundane tasks are taken care of, so they can really focus on the more satisfying elements of work.
Yeah, exactly.
Cool. I think this is a good time to wrap it up for this podcast episode. Thanks again for everybody for listening in. Hit that like and subscribe button, and talk to you next time. Take care, everybody.
See you, everyone.
Thanks.
Bye.
See ya.